Hello, Mr. Oshner. Today we are going to be doing problem number 8 from 7.1, Trig with identities, for my video assignment for week 1. Okay, so we're just going to start off by listing the two identities that we're going to be using for this problem. So right off the bat, we know that we're going to use the even-odd function identity. So that states that cotangent of negative theta equals negative cotangent of theta. And that's just one of our identities that we are given, that we learned throughout this unit. Okay, and so the next identity we're going to be using for further simplification is going to be cosine of theta plus sine, or cosine squared of theta plus sine squared of theta equals 1. Okay, and we're going to simplify that further later. And then I'm just going to define the three trig identities that we're using, or the trig functions that we're actually using in this problem. So cosecant of theta equals 1 over sine theta. Cosine of theta equals adjacent over hypotenuse. And finally, cotangent of theta equals cosine theta over sine theta. And yep, those are the three that we're using. Okay, so next we're gonna just write down this equation in more simplified terms. So cosecant of x equals 1 over sine of x plus cosine of x, and this is going to be multiplied by negative cotangent of positive x, because we're using this identity that we're given here in order to take the negative sign from inside of the actual function itself to in front of the cotangent. Okay, so then we're going to multiply these together. We're going to multiply, actually first we're going to simplify a little bit more. We're going to go cosine of x times negative cosine of x over sine of x. And so if you notice there, we're actually using the um this identity right here, or this trig function right here. We're using the definition of it to realize that cotangent just equals cosine theta over sine theta, or cosine of x over sine of x. And the reason we put a negative there is because we're given that with this identity that this right here is going to be negative. So we have to write a negative sign in front of it. So we're going to go 1 over sine x plus negative cosine squared of x over sine of x. And then, so one thing I just want to be clear of here is um, like this is not this negative sign here is not really in front of the cosine or the sine. It's just a leading coefficient there, because the actual cotangent itself is negative. Okay, so now if you see here, we have a common denominator of sine of x. So we're just going to add 1 plus negative cosine squared of x, and that's all going to be over sine of x. And so we can actually just simplify this a little bit more here. It's just going to be 1 minus cosine of x. Okay, so now we can just take this identity that we have here and use a little bit of algebra to determine the ending value of our actual equation. So, or the final simplification of this right here. Okay, so cosine squared plus sine squared, cosine squared of theta plus sine squared of theta equals 1. And so if we subtract cosine squared theta from both sides, we're going to get sine squared of theta equals 1 minus cosine squared of theta. And so what we are given in our problem is literally this value. So we can just use substitution and substitute this value in for 1 minus cosine squared of x. And so we're gonna plug this in right here, because that's where 1 minus cosine of x is. So we're just gonna go sine squared of not theta, x, over sine to the first power of x. And so if we remember our exponential division rules from algebra, a division is essentially subtraction of the exponents. So the final answer is just going to be sine of x. Thank you.